Figure 3 shows a sketch of the curve with equation y equals 2 sine 2x over 1 plus cos x between 0 and pi over 2. The finite region R, shown shaded in figure 3, is bounded by the curve and the x-axes. The table below shows corresponding values of x and y for y equals this value here. Complete the table above, giving the missing value of y to 5 decimal places. Use the trapezium rule with all the values of y in the completed table to obtain an estimate for the area R, giving your answer to 4 decimal places. Use the substitution u equals 1 plus cos x, or otherwise show that this integral equals this expression here, where k is a constant. Hence, calculate the error of the estimate in part B, giving your answer to 2 significant figures. Okay, let's have a look at this question then. It's a long question, but it's quite simple really, hopefully. So let's have a look at it. We need to work out this value first of all, don't we, for part A, and we can put it in the table. And I'll do that as here now. So it's 2 sine 2x. We're in radians mode, so let's get in radians mode. 4. Okay, so it's 2 sine 2x, 2 times sine of 2 times the x, which is pi over 8, close bracket, 2 sine 2x divided by bracket 1 plus cos x, 1 plus cos of the pi over 8. That's the x value. Close the cos bracket, close the bracket underneath bracket, equals 0.735. Now we need it to 5 dp, don't we? 73508, 0.3508. So use the trapezium rule then to estimate this r to 4 dp. So let's have a look at that then. These are the y values, so I'm just going to copy them and drag them down with me when we work it out. So there they are there. We've done part A, now we're on part B. So let's paste in the formula then from the formula booklet. Here it is here. So we're on part B. These are our y values then, aren't they? So this is y0, y1, y2, y3 and y4. The interval distance is from 0 to pi over 2. So it's pi over 2 minus 0 is pi over 2 here. B minus A. N is the value here, because it's y0 to yn. So that's 4. That's the number of intervals. So that's 4. So h is pi over 8. So when we have h over 2, it's going to be pi over 16, isn't it? So let's put that in there. Pi over 16 goes here. Okay. And then we just need to tap it on the calculator, don't we? So it's the first and the last. So it's 0 plus 0 is 0 plus 2 times basically y1, y2, y3. So we can tidy this up actually and just put a y3 in here. Okay, so these three added then. 0. Let's write it down so it's clear to the examiner. 0.17157, the marker. 1.02280. 2 times that, close the brace, which is equal to, now tap it in the calculator then. So it's pi over 16. So shift pi divided by 16 times bracket. And then inside we've got 2 times all this. 2 times bracket. 0.73508 plus 1.17157 plus 1.02280. Close the bracket for the 2 times, close the bracket for the whole thing, and we want to work it out to 4 dp, wasn't it? But let's just write it down long-windedly. 1.15039, 15039. 1.15039. And then part B, let's just double check we needed to answer it to 4dp. So it's 1.1504. And that's the 4 decimal places. So that's part B. Now part C then. Let's have a look at that. Use this substitution then. U equals 1 plus cos 2x. So let's work out this integral then. Let's just drag this. Save me writing it again. We need to work out this integral using that substitution. So there's our problem, which we'll label as I. And then u is equal to 1 plus cos x, wasn't it? So du dx then, minus sin x. So we can replace the dx by du over minus sin x. Or minus sin x dx is du, any of those. So I is equal to then 0 to pi over 2. Now on the top we've got 4 sin x cos x, because sin 2x is 2 sin x cos x, so that's 4. Sin x is going to be, can go with the dx, and we'll get a minus du, that's the sin x dx taken care of here. The cos x will be u minus 1, won't it? Okay, over 1 plus cos x, which is u. So I think that's what we've got. So let's just double check it. The sin 2x is 2 sin x cos x, making the 4. The sin x and cos x then, well the cos x can be replaced by u minus 1. And the sin x dx, well, if we move that dx up here, and move the minus over, we get minus du as the sin x dx. So I think that's okay. Let's tidy it up then. So we get 4, the integral of 1 minus u over u. So I've run the minus through here. 1 minus u over u. The 4 can come through the integral du. So let's work that out then. That's equal to 4 lots of the whole thing then. It will be log of u, because that's 1 over u when you split the fraction up. Minus 1 integrates to minus u plus k. So it's 4 log u, 4 ln of 1 plus cos x, minus 4 lots of this, plus k. And what did we need to show was equal to? Let's have a look here. So we just needed 4 log minus 4 cos x plus k. Well, our k here, we can just adjust that then, can't we? So it's 4 ln of 1 plus cosine x minus 4 cos x when we expand the bracket. And then we've got minus 4 plus k, which we can write as plus k dashed. Here k dashed is equal to k minus 4. So there's our answer to part C then in the form that was required. And we've done that. But it was the integral between 0 and pi over 2 we were interested in, isn't it? So now we need to do the definite integral to work out the estimate of the error to 2 significant figures. So for part C then we need to get rid of these definite bounds, of course. We've just done here when we copied and pasted it. Part D then. So now the bounds, the answer is equal to, so the integral, not the answer, so the integral, I'm going to have to write it out, pi over 2. Again, I need to erase this here from before in the previous section. So it's the integral between 0 and pi over 2 of this. 2 sine 2x, let's write it out long-windedly, over 1 plus cos x dx will simply be equal to this thing here, 4 ln 1 plus cosine x minus the 4 cosine x between pi over 2 and 0. So let's see what we get then. That's equal to top value, pi over 2 in here. Cos pi over 2 is 0. 4 log 1 is 0. But let's write it down. 4 log 1, top value. Pi over 2 in here is 0. Take away bottom value, put 0 in. 4 log 2. Here, when we put 0 in. And minus 4 cos 0 is minus 4, isn't it? Close that bracket at the end. So we got 4 log 1, which is 0. This whole bracket is 0. So we end up with then 4 minus 4 ln 2. Okay, so now before, that was part C. Part D rather, we don't want the error to two significant figures. Okay, so the error then. So error is equal to this value, 4 minus 4 ln 2. That value. Take away the estimated value, which will be the smaller value, won't it, using the trapezium rule. 1.15039, 1.15039, or 1.1504. Let's write that down. And tap it in the calculator. So we've already got that number here, thankfully, the exact number. So what I'm going to do is just find the difference. So take away, bracket, 4 minus 4 log 2. And this should come out negative, shouldn't it? Because we've written it around the other way. And then close that bracket. So our answer will be, flip the negative, 0.07 to 77, 0.077. And that's the two significant figures. And there's our error term.